All right, so as promised, I was going to allow you to use the period to work on Project 4 and, of course, field any questions. I think last time or sometime in the past I was asked if that error class exited the program, and I think I said yes, and if I did say yes, I was mistaken. The answer is no. So the question is, what do you do if there's an error? And generally, after you generate the error, you don't want to do anything else in that code block, right? The code block being whatever code you have affiliated with that particular production rule in the Bison file. One strategy is to say if the index is less than 0, then you error out. Else, if this other problem, then do this. Else, do everything you normally do if it's good. If you want to get out of your code block prematurely, meaning if there's a problem, generate the error message, then get out, then if you look at the gpl.tab.c file, right, the file that's generated from the Bison file, you'll note that all of your code sits inside of the case for a switch statement, or cases, right, for the different code blocks you have. So if you want to basically abort your code after generating an error, just put a break in there, and that'll break out of the switch statement it's inside of in the generated code. So I wanted to throw that out to you. Are there any questions that I can answer for you that you want to ask? Yeah. Errors out's not defined. So you have to, is that around that simple type? Okay, so let me come back in here. Now, did you take note of this stuff that I had? Hang on. Did you do the things here? That should be sufficient to get rid of them. So I'll go ahead and look at your code offline, and we'll see if we can resolve it. Any other questions? Yeah.
Yeah, I ran into the same problem. So basically, you gotta go to the parser.cpp and put the header file above the.
In parser.h, right? Not parser.
Yeah, sorry, parser.h. You gotta put the header file above the gpl.tab.h. Otherwise, it won't work. You gotta, the order matters when you include the header file. If you put below the tab.h, it won't work.
So right here where it says put new included above this line, right?
Yeah, above that.
Yeah, so this is parser.h. So that's another thing to check then. What else? Okay. So what I'll do is I'll go ahead and let me think if there's anything else to talk about. Let me ramble a little bit about the symbol table. And it being a singleton. It's public we had as private the symbol table constructor. And the strategy, let me see what we had for the instance. We had something like So I'm trying to recreate this in my head, so let me know if I get something terribly wrong.
Did you set such that tab pointer equal to null pointer when you declare it in the .h?
Yeah, I think that's probably allowed in the 2011 standard on. I don't recall the specifics of it, but I believe it's from that point on that you're allowed to do it. My problem is I cut my teeth in the 90s on C++, so I end up resorting to more traditional ways of initializing things.
So the way you're doing it right now, it's not in a function, it's just floating in the .cpp file.
Yeah, and I'm actually not sure you can get away with not doing this. For instance, I think you might be able. So let me. I'm not sure if it only applies to static variables. I'm just not that in tune with what the standard allows and doesn't allow for that liberation of initializing on line 6. I believe that regardless, you still have to define the variable. So in the same sense that just kind of avert your eyes and forget about static. Just pretend this is a normal class. On line 3, that would be the declaration of a member function, and you're still responsible for defining that member function, right? Providing that function with the curly braces and what that function does. So in the same sense, when you do line 6, let me just get rid of this. That is declaring the existence of the variable, but it isn't defining it in the same sense that it isn't defining a member function. So normally what I'd have down here in the .cpp file is this would be the static variable definition. Okay. So I believe regardless of this whole discussion, I believe you're still going to have to define that variable. And then that variable, since it's static, comes into existence at the beginning of the application run. So this, I believe, is the code that I passed on to you last time. I was messing around with it some, and what I don't like about this is that there's no easy way to release that memory that's dynamically allocated right there. So I believe a superior implementation of this would be to change this from a pointer to an actual variable. I'll leave the name the same even though it says pointer. Now it's a little misleading. And by doing so, this would just simply be to return the address of that variable. Now the advantage to this is that I can now write a destructor And in this destructor, I can iterate through, what else do we have? It's private, a unordered map. Right, so that's I think I like this implementation better than the original one I presented you because it's just a little bit more cleaner with memory, and it'll specifically go out there and release all that memory that the unordered map is pointing to. So that's something for you to consider depending how far along you are. Any questions on that? Any questions on anything else? Okay. Then I'll go ahead and stop the recording here, and then I'm happy to take individual questions if you want to show me code and so forth. Otherwise, we will pick it up on Tuesday.